All right, so this unit is all about rational numbers. All that really means, guys, is fractions. Don't let that freak you out. We'll be able to work through this just fine. Keep in mind the rules of fractions, but that's basically what's going on here. The other thing is, always remember the first thing you want to do in every one of these problems is factor from what we just learned in our last unit. Okay, so rational numbers are where we bring in fractions. It includes practically every number that we know, but that's where fractions first show up. And so we think of rational numbers as fractions. Okay, so a number over a number. Okay, so we're going to start with reducing rational expressions. Well, it's no different than just reducing fractions. So let's say I have a number like this. What is the biggest number, the same number, that can divide into both the top and the bottom evenly? Well, I can divide 3 into this, and I can divide 3 into this. So 21 divided by 3 is 7, and 15 divided by 3 is 5. And this is my reduced fraction, okay? Ours are just, our numbers will just, or expressions will just be a little more complicated than that. That's all. Okay, so let's get started. Let's try some of these. 108g to the 4th divided by 9g. Okay, so I always look at the numbers first. Okay, 9 can go into itself once and into 108 12 times. And then the g's are the same. So technically, guys, what I'm doing is subtracting the exponents, the bottom exponent from the top exponent. If that number, that exponent ends up being positive, it stays in the top. If it ends up being negative, it stays in the bottom. In other words, subtract the two exponents, and wherever it was bigger to begin with, that's where it stays. In this case, we're going to leave it in the numerator because that is the bigger number. So I can get rid of 1g, I can get rid of 1g here, and I'm left with 3 of them. So my final answer then is 12g to the 3rd over 1, which I don't write. Okay, let's do some more examples. 10d minus 5 and 12d minus 6. Well, first thing I need to do before I can do anything is factor. So let's look at the numerator. Rule number 1, are there any greatest common factors? Well, there are, and that leaves me with 2d minus 1. Let's look at the denominator. Any greatest common factors? Yep, that leaves me with 2d minus 1. Now, you cannot, under any circumstances, cross-cancel the 2d and cross-cancel the 1. That is not acceptable. Okay? Let me redo this. You can only cross-cancel things when things are being multiplied. 2d. And the 2d minus 5 are being subtracted. The 2d minus 6 are being subtracted. But this whole thing, the 2d minus 6 is one thing. These ended up being 1. Sorry, can't talk and do this at the same time. These ended up being the same thing, so the whole thing, anything over itself equals 1, and our final answer then is 5/6. Okay, I'm sorry if I confused you on that one. We'll keep doing some more so you won't get too confused. So our third example is 3c squared minus 36c plus 96 over c minus 8. Now, do not, under any circumstances, take these apart. Work the numerator's first step, then the denominator's first step, Then next work the numerator's second step and the denominator's second step and keep going. But if you take these apart and work just the numerator all by itself and then just the denominator all by itself, I can almost guarantee you by the time you're done, you'll get it all mixed up. So here's how we do this. I'm going to look at the numerator here. Rule number 1, are there any greatest common factors? Well, yep. So I could factor out a 3. That leaves me with this. Okay, that was the first step. Now there's nothing I can do in the denominator. So let's keep going. So rule number 2 in the numerator, is it a binomial? Nope, so it's not a difference of squares. Is it a perfect squared trinomial? Is it a trinomial? Yep, maybe it's a perfect square trinomial then. So is this sign a positive? Yep. Can I get an even square root of c squared? Yep. Can I get an even square root of 32? No. So it is not a perfect square trinomial. So then we go on to rule 3a. So I've got my 32, 1 and 32, 2 and 16, 3 doesn't go into it, 4 and 8, 5 doesn't, 6 doesn't, 7 doesn't. I've already got 8. Looks like this pair will work if I do -4 and -8. When I add those two together, I do get -12. Last critical step, negative times a negative is a positive. That's what this guy is. I'm good to go. Does this sound a lot like our last unit? Oh, now look. C minus 8, anything over itself equals 1. And what I'm left with is C times the quantity C minus 4. Now I could distribute that 3 if I wanted to. Keep in mind when we are doing these things, the numerator can stay in factored form or it can be in multiplied form, but the denominator must always stay in factored form. In this case, it doesn't matter because it's just a 1. Let's go on to another one. I'll do as many examples as I can in the time that we have. So u, v, see if I can keep my v's and u's looking like u's and v's, 3u minus 4v, and not x's, v, over v squared minus 9. Okay, so rule number 1 on the numerator. Any greatest common factors? Nope. Rule number 2, it's not a binomial or a trinomial. Rule number 3, it's not a trinomial. So rule number 4, it does have 4 terms, so let's factor by grouping. So I'm going to look at these two. I can get out a u, and I'm left with v plus 3. And then I can get out a minus 4. Remember, that changes the signs to everything behind it. And so I've got v plus 3. That's just step number 1 in the numerator. Now I'm going to do step number 1 in the denominator. Well, let me look at it. Rule number 1, any greatest common factors? Nope. Rule number 2, special factoring form. Well, it is a binomial, so maybe it's a difference of squares. And my negative sign also makes it seem like it might be a difference of squares. So can I get an even square root of v squared? Yes, v. And can I get an even square root of 9? Yep, 3. So it is a difference of squares. So v plus 3, v minus 3. Now I need to do the next step in the numerator. So my greatest common factor is v plus 3. I'm left with u minus 4. Nothing more I can do in the denominator, so I'll just write these down. Now, everything is completely factored. Now I'll look and see what I can cross cancel. Well, v plus 3 can go away, and so I'm left with u minus 4 over v minus 3. And I don't need to put those in parentheses because the numerator isn't being multiplied with anything else, the denominator is not being multiplied with anything else. Let's see if we can get one more in here. So, our fifth example. You're going to love this one. Q minus 11 over 11 minus Q. Well, let's look at this very carefully. There's nothing to factor exactly, but if you notice, what's in the numerator is exactly opposite of what's in the denominator. In the numerator, I have a positive Q, and in the denominator, I have a negative Q. In the numerator, I have a negative 11, and in the denominator, I have a positive 11. So these are exactly opposite of each other, okay? Well, there is one thing I can do to change both of the signs of one of these. Only do one. If you do it to both, you're going to be in the same boat. And that is to factor out a negative. You can do it either in the numerator or the denominator. I like to do it in the numerator because that helps see things. People usually get all mixed up if they do it in the denominator, but you can do it that way. So remember, when I factor out a negative, it means both the signs of the other things have to change. Well, now, even though they aren't in the same order, what I have in the numerator and the denominator now are exactly the same thing. In the numerator, I've got a negative Q. In the denominator, I have a negative Q. In the numerator, I have a negative 11. In the denominator, a positive 11. And in the denominator, I have a positive 11. Anything over itself equals 1. So, but remember this guy. Okay? Whoops. We don't want to get rid of him. What I have left is negative 1. So keep that in mind. Have fun with these guys.